Uh, we'll introduce a new topic today. Last meeting we have finished the instruction cycle. Okay. Ngayon we will talk up. We'll discuss interconnection structures. Then we'll proceed to memory. We already had a brief preview of the interconnection structures when we look at the structure of the CPU, because the CPU inside the CPU is a set of connections that that connect the registers to the ALU, to the CPU, and to the instruction register. No, so kailangan there must be always a set of wires, no, or a set of interconnection structures that will connect the internal registers of the CPU itself. No, do you follow? So that is called the internal bus. Okay, ang tawag diyan bus. Bakit bus? Because it's just like a school bus which sends a batch of students to school. Jesus. Diba? Kaya tawag dyan bus. But instead of students being sent to school or fetched from school, it's a set of bits. So sabay lahat. For example, if the bus can contain 20 students, all students will arrive at school at the same time. All students will depart from school at the same time. The only difference is in a school bus, the students when going home may go to different destinations. In a computer bus, all the bits will derive from one source and will go to one destination. So pareho sila ng source, pareho sila ng destination. Do you follow? So there are two sets, the classic bus architectures. These are the parallel architectures. Kasi dati parallel. Katulad nga ng school bus, pwedeng 8 bits, which means that 8 students are being sent at a time. Okay. So the term bus was there already a long time ago. But in the IBM PC, it started in 1981 when the IBM PC was produced. It is called ISA, or interconnection systems architecture or standards architecture. Let me make sure. Computers. Bus. ISA bus. Okay. Industry standard architecture. ISA bus. Do you follow? So it came with the IBM PC, and the bus is 8 bits originally, which means that it can send and receive data by a bytes. They follow 1 byte at a time. So let's look at the 1981. It's called the ISA. Okay. So there are 2 parts of the bus. Yeah, it has an address, 3 parts. An address bus, a data bus, and a local bus. What do we mean by the local bus? The local bus is the bus which is inside the CPU. Okay, inside the CPU, and which maybe the memory is usually part of the local bus. Sometimes there's a separate bus for memory because memory is much faster than other I/O devices. Sa I/O na tayo nag-usap dito, So why is it called a bus? Because it sends and receives data, a group of bits at a time. So the original bus is called ISA bus. So ngayon, inabutan ba niyo yung mga, di ba, are you fond of games? Yung AGP, all graphics port adapter, di ba? If you are fond of games, most probably you are. So computer buses were divided into internal, north bridge, and south bridge. Ang front north bridge is a bus actually. Actually, it's a bridge between buses. A highway pala, The north bridge is the fast lane. There are 2 buses. There's a fast lane, kumbaga merong expressway, merong traffic way, normal traffic. The fast lane is called the North Bridge, and it's connected to the front side bus. The front side bus are where the USB and the external devices are connected. And the North Bridge also bridges together, no, the front side bus, which is connects to the CPU and the memory and the all graphics adapter. So ito yung mabilis na bus, no? North Bridge bus. And then there's a South Bridge bus where the PCI and the ISA are and the SATA, no? And the USB. Yung mga hard disk saan nakakonect. Okay? Do you follow? The original bus is called ISA. It's an 8-bit bus, no? And it's parallel because it sends and transmit data 8 bits at a time together, no? Together, no? Hindi siya pa isa-isa. Okay? So nowadays there can be, in terms of data transmission, the bus can be parallel or serial. Ibig sabihin ng serial, 1 bit at a time, isa lang yung pasahero at a time, but it's a very fast bus. Nowadays, no, ang uso ngayon is a very fast serial bus, yung tinatawag na Intel Quick Path Interconnect, which is used to connect PCI Express, di ba? Have you bought your graphics card lately? No. Anong port? It's called, the interface port is called PCI Express, okay? So a bus is usually has an address bus or a data bus. No, the data bus is connected to the memory buffer register. Ito yung nagko-contain ng data. The address bus goes to the memory address register. This is the bus and the PC and the IR. No, this is the bus which contains the address. No, sometimes of course, no, a bus has a speed like the CPU. No, a frequency of 1 megahertz, which means that it can send or receive 1,000 megabits. 1,100 megahertz is 100 megabits per second. Okay, so 8 bits at a time, that's divided by 8. So how many bytes it sends? Okay, so the main throughput is the data transfer rate is in bits per second, and sometimes it's called megabytes per second. No, kung capital B, megabytes yon. Kung small b, no, that's bits. So ito yung mga examples ng mga buses, no? AGP, serial ATA, yung pag-connect sa mga hard disks, and then IDE, also the old, no, IDE for connection of hard disks. The PC card, where you connect your modem, yung mga Wi-Fi, no? And then PCI, where we connect your sound card, your whatever you connect, no? Okay, the SATA bus, and of course there's the USB, no? The firewire and are all connected to the PCIe. Okay, these are the most common buses nowadays, no? SATA, eSATA, no? SATA 3 na tayo ngayon, so that's very fast, no? PCIe, that's the standard. USB is top, no? Is bridged through the PCIe bus so that you can have through a host, no? So meron din siyang sariling CPU. It's called a USB host. Okay, Thunderbolt connected to USB-C cable, pero separate pa ba yan ngayon? Hindi na, di ba? Where do we get an ISA bus, no? Okay, so ganito yung traditional, no? But that's no longer the case nowadays with quick path interconnect, no? Wala na tayong separation between North Bridge and South Bridge. Okay, ISA bus. Bakit wala akong ISA? Okay. Dapat nandun, no? Kasi dapat meron tayong let me just Google it na lang, no? Ito yung ISA bus, oh, the original IBM PC. Ganito. Ito, extended ISA na ito. You follow? ISA bus architecture. Kasi gusto ko makita yung yung address bus saka yung data bus. Okay? Meron ako nito no? Nalimutan ko lang. Let me just Baka nandito lang sa Wikipedia, no? Yung layout niya. Oh, ito. Okay? Can you see that clearly? Mahina, no? Can we sort of, ito yung original ISA. 8-bit. Okay. Ito e-ISA na ito. Pag meron ng extension, J1 and J2. Ang tawag dyan, no? J1, sorry. Is the original. Bakit nawala yung aking ano? Anyway, nandun na siguro sa ano. Okay? Ito yung ISA bus na slot. The other one on the right is the extended ISA. No? So, if you look at this, no? Ito yung slot na kung saan mo siya i-insert. Your sound card, your printer card, no? Your modem, your serial ports, dati isasaksak mo yan. Okay? So, this is an 8-bit bus. Look at that, no? It has data pins, no? Dito sa ano? Okay, data 0 to D7. They follow? So, 8-bit bus siya. And it has 20-bit addresses. Kasi dati, 20-bit address lang naman talaga ang IBM PC. Ibig sabihin, 1 megabyte lang. 2 to the 20 is 1 megabyte. Is that correct? Can you check that out? I-check na natin. Equals 2 to the 20. Okay? 2. 2 raised to the 20. Exponent. Where's the exponent? 1 megabyte lang. Okay? Dati 1 megabyte lang yung pwede mong ilalagay sa IBM PC because it's not a Windows operating system. No? So, text-based lang siya. And you have to make do with it. No? Do you follow? No? 1 megabyte lang. So, the address is only 20 bits. That is from address 0 to address 19. Acknowledge enabled. Okay, so there's a memory read, memory write, no, and many other signals. These are control signals, no, from the control unit from the CPU. So meron din siyang interrupt request line if an interrupt is sent, no, by IO device over the bus. Okay, so IO write, IO read, no, i-distinguish niya yung memory read saka yung memory write. Okay, so there are interrupts, no? Now, if there's an IRQ request line, no? So there are interrupt numbers. 7, 6, 1, 2, 3, 4, 5. So 5, 2 to the 5. That's the number of IO devices you can connect. Okay, because each bus can have 5-bit interrupt lines. Okay. Although ang keyboard meron na siyang sariling port, no? Do you follow? So this is called the IBM PC XT. XT, no? I'm not sure what XT means, but when you say XT, it's an 8-bit bus. Now, there's an IBM PC AT, no? Which is a 16-bit bus. It's called e-ISA, no? Actually, makikita na rin natin dito, no? The e-ISA bus, which was introduced in 1988. Now, this is usually used for servers, no? So, kung IBM PC XT ka, you're just a desktop user. If you are using IBM PC 80, you are using it for high speed, no? Kasi 16-bit, which was introduced in 1988. 1981 yung ISA, no? Yung e-ISA, extended ISA, PC, personal computer, extended ISA. So, ito yung pagkakaiba nila, no? Sorry, kasali na dito yung PCI. Ito yung PCX, ang 80 bus includes J1 and J2. They are set of pins, no? Okay? Pag J1 and J2, ibig sabihin 80 bus ito. It means that it's a 16-bit bus, no? Kasi ganito lang yung, this is J1. So ang J1 nandito yung sa pin 9, okay? Sa pin 9, 2 to 9 is actually the byte being sent. Okay? So 2 to 9, pins 2 to 9. So dyan yung data. Tapos yung address, no, is in it's still a 20-bit address, no? So 1 megabyte pa rin ang pwedeng ilalagay na memory, no? Do you follow? So pins 12 to 31 is the address bus. Okay? And 1 to 8, 1 to 2 to 9 is the data bus. You may say kasi ang J1 lang yung ISA. Do you follow? Now in the EISA there's an extension like this, the number of pins, so that 8 new bits are added for data. Nandito sa J2. Do you follow? So you have the second byte. This time it can now send or transfer 1 word or 2 bytes at a time. Do you follow? No? So ito 'yon. Pag ganito yung bus mo, no? You can now install a graphics card. Okay? So ito graphics card ito, VGA. Meron ng small low resolution VGA. Okay? Low resolution VGA, colored na yung monitor mo. Okay? You can now have a color monitor on an eISA. Doon sa ISA bus, which is PCXT, pasensya ka na lang. It's a green monitor. Okay? Do you follow? Any questions so far? So that's the main difference, no, between ISA and eISA. eISA came in 1988. It was invented by Intel. Okay? Any questions so far? Okay, so yun yung bus. Parallel buses ito. Okay. Now, in 1994, no, Intel developed a PCI bus. PCI na tayo ngayon. Okay? Even now, PCI compatible devices are still available, no? So ito yung pin layout niya, no? Now, the good thing about this is the PCI can come in 2 versions. There's a 5-volt card or a 3.3-volt card, no? Pwede siyang 3.3 volts, which is hindi siya masyadong mainit, no? Okay? So ito yung mga pin. Have you seen a PCI PCI So ang addresses, okay? AD14, AD12, AD so this is a 16-bit bus. Okay? 16-bit bus pa rin siya, AD15, okay? So nandiyan yung mga address niya. Do you follow? Okay. Now there's no date. Is there a data? If there's no data, then this is kasi address lang no? Wala yung data If there's no data, then there's this serial. Isa lang yung data niya. It has an address. Oh no, it's a 32-bit address. Take a look, no? PCI is a 32-bit bus, no? Do you follow? So meron din siyang interrupt request line. And now there's no data. There's no data. So which means that this is serial. Okay? Hanggang 32 yung kanyang address, 3102 31. Okay. Ang dami niyang ground connection para mas madali siguro magano. Okay? So this is a serial bus. Serial siya, but this is high speed. So meron siyang bus master devices. Kasi serial siya so dapat kailan siya i-synchronize. (64-bit? Can PCI be 64-bit? Yeah, address niya hanggang 32 lang 0 to 31. So it's a 32-bit bus. So anyway, you don't need a 64-bit outside the CPU. No? So these are the connections you can make. No? A SCSI driver. No? It's a like IDE. No? It's a parallel bus dedicated for fast hard disks. If you have a SCSI hard disk, it's like the what is that called today? SSD of the old times, no? But this is very sensitive, We had a SCSI hard disk once which got destroyed because it was placed on top of a table where the table was dragged manually. So nasira yung SCSI. Kasi ano, sensitive siya. Hindi siya pwedeng basta-basta galawin. So 1 megabyte per second. It was already considered very fast. No? Okay. Data transfers can go up to 4 Mbps in synchronous mode. Okay, which means that hindi pwedeng fully synchronous, which means that one at a time, no? So merong data request on the bus. Okay. So that's the PCI bus, no? Where do we have can we get a picture? Ito yung PCI bus, no? Ganito. Meron siyang local bus, meron siyang old, okay, bridge, no? To all devices. The PCI local bus is 32-bit, ISA is 16-bit, so pwede ka rin maglalagay, okay, ng old for backward compatibility. So there's a motherboard of PCI. So ganito na tayo ngayon, di ba? Ganito na yung PCI slot natin. Okay? But this is not, the modern PCI is no longer PCI but PCI Express. Okay? Now, in a parallel bus, only two devices can use it at a time. Hindi naman pwedeng kumbaga one set of students, not two sets of students, no, can ride a bus, no. Yung second set, second batch na yun sila, di ba? Okay? So there must be bus arbitration. Bus arbitration is an algorithm that is used by a bus controller. This is called a bus controller, no? A bus controller is a CPU which does bus arbitration, no? Ang bus arbitration is an algorithm which decides which devices can use the bus at a time, no? So meron tayong tinatawag na bus master, no? This is called the controller. The controller that has access to the bus is called the bus master, no? So meron tayong controller device, no, that controls that does bus arbitration. There are two types of bus arbitration, no? Centralized bus arbitration. Isa lang yung arbiter, which means there's only one bus master, and all those that need to use the bus or transfer data through the bus must perform requests, perform requests to be granted by the centralized arbiter. No? Do you follow? Now, distributed bus arbitration is unahan. Okay? Do you follow? I get to lock the bus not until I release it will others be able to make use of the bus. Okay? So centralized bus arbitration is there's an arbiter. Now, distributed bus arbitration, all devices can request at a bus, at the use of the bus at a time. Okay? Sa centralized bus arbitration, there are several methods, no? Okay? They follow daisy chaining. There's polling, and there's fixed priority. Okay? They follow? Okay. Ang PCI is distributed bus, which means merong send and acknowledge, no? So i-send niya kung free yung bus, the bus will acknowledge. If it acknowledges, it uses the bus. Okay? So these are all done by the arbiter, no? Okay? So since daisy chaining, no, requests are granted on a queue. Okay? Depending on the bus cycle, it's like a pipeline, no? They're presented in a pipeline in an instruction set. Okay? Cardinal. Pipeline in an instruction. So kung may pipelining ka, instruction fetch is faster because you don't fetch on one instruction at a time. You fetch, say, 2 instructions at a time. I-fetch mo muna yung dalawa habang nag-execute yung isa, the other one is being fetched, so that when the next instruction is going to be executed, it doesn't have to be fetched. It's already there in the pipeline. Okay? So ganun yung daisy chaining, no? Device 1 sends a bus request, and then the bus sends an acknowledgement, and then the arbiter, okay, chooses, for example, to use device 1 because it is the first. Meron na naman coming. Who's the new, ano? Sinong bagong pasok? Cardinal ba, di ba?
Ay, na-record na po ako, sir.
Sino, Cardinal?
Ay, Jesus po, sir.
Yes.
Medyo late po ako. Sige po.
Na-record ko na, no? Jesus. Yan, no? Okay. Di follow. So, ganun yung daisy chaining, no? When there's another request, it's just queued to the line, no? And then this is a bus request from the device. This is the acknowledge, no? This acknowledge from the device also when it's done. Okay. So for example, device 1 is the first, so it's being granted use of the bus, and then when it's acknowledged, it's released use of the bus, and then device 2 is now allowed. Okay. And then once the acknowledge is sent, so it's assigned niya daisy chaining, no? It's like actually a queue. Okay, a normal queue. So naka-daisy chain sila, one at a time they are granted depending on the request, no? First come, first serve. Okay? Now the advantages with daisy chain bus arbitration, this is done in ISA, no? ISA, daisy chain din lahat. Simplicity and scalability. The user can add more and more devices along the chain. No? Pwede kang magdagdag ng maraming devices. Now, sometimes, no, when you get to the disadvantage is when a slow device gets to use a bus, all the fast devices will have the same speed of the slowest device. It's like ano ba yun, sa Green Lantern, no? The team is only as strong as its weakest member. So no matter how powerful your team is, you're only as strong as your weakest member. Green Lantern. Ano, did you see that? Okay. You're only as strong as your weakest member. Ganon din yung sa daisy chaining. It's only as fast as its slowest device. Because when there's a slow device connected to the bus, everybody will have to wait for the for the device to finish, and the speed will be according to the slowest device. Okay? Wala na tayong masyadong details dito, no? Kasi mahirap magtingin ng mga motherboard. Ano? We just have to, even in our class before, no, they just enumerate this. If one device fails, then the entire system will stop working kasi naka-waiting yung iba. Okay? Another alternative to daisy chaining is polling or rotating using priority method. So bigyan na ng priority. Okay? For example, when the next device comes, no, iti-check lahat ng devices for their priority. If the next device comes has the highest priority, it will go to the first of the stock. No? So hindi na siya queue. Stock na siya. And that's not just, no, basta priority, no, priority queue. I'm sorry, no, priority queue. So where devices are arranged according to their priority. Usually the fastest devices are the highest priority. Okay? Okay? Simple rin ito. Okay? Pero ganun din. Pag merong isang nasira dyan, the whole system will, no? It will not stop working, no? You can just proceed to the next priority. Okay, kasi prioritized, no? Do you follow? Okay. It will favor. It does not favor. No, depending on the priority, no? Siyempre, no? Kung mas mabilis. Okay? Mas, walang mas priority. Rotating priority pala ito, no? Which means priority. Dito naman pangatlo is independent request method, fixed priority. Depende sa interrupt request line, no? Kung ano yung priority yung number niya. Okay, certain numbers assigned high priority. Ito pala rotating priority, which means that for now you are the first priority. The second time around, another one will have the first priority, no? So distributed yung priority. For the moment, if you get the first priority, next time around you are the lowest priority. Sa fixed priority, no? Certain devices, depending on the IRQ request number, are given the highest priority. Okay. This is the fastest, no? But the hardware is costly. Okay. So, marami pang references, no? Bus arbitration. So, modern interconnection structures. Ito na yung bago. By 1997, no? AMD introduced hyper transport technology. It was introduced in 1997, but was actually used in 2003. It's called hyper transport technology. Is it really hyper transport? In a way, no? But is it unique? No. Kasi ganito yung ano niya, no? Ang North Bridge, it has several North Bridges. Okay? So that you can connect multiple CPUs. AMD first invented this, no? Do you follow? You can connect multiple CPUs in the local bus together. For example, if there are 4 North bridges, no, you can connect 2 Athlon CPUs in each bridge, and then there's not just one line, there's not just one bus, but between bridge to bridge, there's another line. For example, one CPU wants to communicate to send data or another CPU, no, to this bridge. It doesn't have to use to send request because this is a dedicated line. No? So four CPUs, when 4 CPUs are connected together, they can just use the bus anytime because CPU 1 can connect to CPU 2, CPU 3 can connect to CPU 4 anytime. No? It's not just a shared bus, but a dedicated multi-connection bus. No? Where did they, paano nila ito na-invento? Because during 2003, nauso na yung sa network technology. The network technology has changed, no? The invention of the switches, network switch, kasi dati ang uso is hubs, where hubs are public. That also explains the difference between a wireless router and a connected switch, di ba? Kung mag-connect ka sa wireless, you will compete with the others who are connected to it because it's public. Ibig sabihin, kung 1 Mbps yung Wi-Fi, tapos 10 kayo, you will only have 100 divided by 10. No? So, the concept of networking switches was adopted by AMD. I'm sorry, no? Andali lang. No? I'm sorry, no? There's a disturbance, dapat i-silent. I haven't time. So that's what how the hypertransport works, no? So there are multiple bridges, just like assigned to a network switch, no? Sandali lang talaga. Sorry, no? So, ganun yung concept ng AMD, no? So, it was used in K6, K2, no? Yung mga CPUs, no? That use hypertransport to PCI bridge chip, no? So meron siyang chip, no, which you connect to your PCI bridge. So pwede, the north bridge chips can then be connected to the south bridge over an interface controller using the same hypertransport bus. Okay? So serial bus ito, no? Serial bus pero high speed siya, and this is better, this is faster than the parallel, ano? This turns out to have faster data transfer rate. Now, incidentally, no, Intel also invented their own version of hypertransport, no. It's called quick path interconnect. Ito yung this is a document directly from Intel, no. So this is intended to be this embedded in the processor, no. Okay. 2004, no. You have a chipset shared front side bus until 2004, 4 gigabits. So meron ang front side bus is the bus that connects the CPU, no, together, no, kasi pwede ka nang mag-multiprocessor. Okay, dual independent buses by 2005, no. Ibig sabihin, the chipset now contains two buses such that two processors can be connected on the same bus. Parang hypertransport talaga siya, no? Do you follow? And by 2007, it has now independent high-speed interconnects, which means that each processor has its individual line to another processor. No, 1:1. Okay? Do you follow? So ganito yung Intel Quick Path Interconnect. If you have four processors connected together, no? Processor A is connected to processor B, and processor B is connected to processor B. Gano'n, no? Do you follow? So they can now interact directly without having to request for bus. Ibig sabihin, they have exclusive use of the highway. Sila lang dumadaan doon sa highway na yon. Okay? So there's no traffic. And then there's a chipset which connects. Okay? The CPUs to the I/O devices. So the quick path interconnect is actually a multi-processor bus system, I/O interconnection system. So all processors also are directly connected to memory. No, dedicated yung connection ng processor to the memory. Kasi kayo, nauso na dito yung 2007 multi-core. Do you follow? Dito na nauso yung dual core. Do you follow? Quad core. Do you get my point? Doon sa old buses, old PCI, single core lang. Now we can have multi-cores, no, connected together. So we have a different interconnection system. Okay. So this is explained in our book, no? The architectural layers, no? Yung connection between there's a transport layer and there's a data link layer. It's really just like a network, no? May protocol siyang ginagamit, there's a transport. You're taking network systems, right? So meron din siyang physical layer. It really like connects the processors together in a switch, no? So merong interconnections. We'll try to solve problems with this, no? Explain naman niya yung problem dun sa ating Okay? So this is called the Intel Quick Path Interconnect. No? So multi-processors by 2007, no? Pati yung AMD multi-processors na rin by 2003. Okay? Let's look at the actual the actual that's just the pero may motherboard ba tayo? So nauso na ngayon dito, on the other hand, is the PCIe. Liit-liit naman itong Okay. Dito yung chipset, no? This is the chipset which connects the hypertransport, no? Which connects the different cores together, no? Bakit? Okay. typical configuration PCIe. Bakit mahina? Can we just download this? PCIe diagram pala. Okay. What is PCIe? This is a top, no? Hindi natin makita kasi yung no? Yung QPI, PCIe diagram. Bakit hindi? We don't know this. I'll try to look for no? Dito yung chipset which has the interconnect, and then it can connect to several PCIe devices, no? Na meron kang directly, no? Which means that there's a gigabit Ethernet, one connection directly to the CPU. No? It's not connected in a separate bus. Sa PCIe ngayon, there are several devices, like there's a unique bus connecting the memory to the chipset, connecting the to the old PCIe bridge. For example, meron kang old PCI, no? Iko-connect mo siya doon, okay? Okay? And then there's a PCIe host which connects, okay, the chipset to the different individual PCIes, no? So direct connection ito from the chipset, okay, to the hard disk, no? To whatever PCIe devices you have. So reduce this is actually increased parallelism. Serial siya pero lesser yung sharing of devices, sharing of the bus because of the interconnection, no? Interconnection. So wala masyadong bus sharing, wala masyadong bus arbitration because there are dedicated lines connecting the chipset to its PCIe. There's also a connection to the old PCIe bridge, no? So pwede ka rin mag-connect sa old PCIe. I hope I can get a bigger picture, no? So PCIe is an extension of quick path interconnect. Nasa labas siya ngayon ng chipset. Pero it's still dedicated, it still has dedicated lines, no? So the devices that are connected to the PCIe or PCIe Express are called PCIe devices. So they come in different sizes, right? But have you seen this? No? No? So multiple na siya. The biggest is a PCIe 16. Yung mga graphics card, yung mga are 16-bit devices. Wala pa tayong 32-bit device, no? Na PCIe. Ito yung PCIe Express 16. Okay? 16-bit. And then you have PCIe 1. You have PCIe Express 4. Yung mga Wi-Fi. And you have an 8-bit PCIe Express. Okay, for all PCIe. Ano bang nilalagay dito ngayon? Mga USB, mga no? Do you follow? Okay. So ang mga EGP usually comes in a PCIe Express 16. Okay. So the PCIe Express bus actually works like a network switch. It also has a protocol levels of protocols, no? Network layers. Okay. Pero ang difference lang nito is there are dedicated lines. Like for example, the graphics card is directly connected to the PCIe, to the chipset, okay, which connects to the CPU. Okay, do you follow? The chipset now is like the bus arbiter, the bus master. Okay, hindi katulad dati na you have a separate bus master and you have a shared bus. Ngayon, we have a bus master which has independent connections, no? Independent connections to the hard disk, independent connection to the Ethernet, independent connection to the USB. The USB will have its own host, no? Do you follow? Okay. Any questions so far? Okay. So that's just one chapter, no? Sa ating that's called the top level view of a computer. We have the instruction cycle and we have the interconnection structures. Okay. I'll give you your activities next meeting na lang, no? Para wala kayong problema. And then we will start discussing memory next meeting. Okay? Any questions so far? Okay? So that's up for now. No? That ends one chapter in our book, no? One long chapter, one very long chapter, no? Okay? So next meeting, we will discuss memory. Okay. Medyo mahirap-hirap ito. Okay. Any questions? So see you on Monday, no? When will our class end? March, no? Or April?
We
March,
don't
sir.
know yet.
March lagi daw?
March.
So 1 month. Mga anong, do you have a class calendar? Do you have a class calendar? Kasi nawala ko yung aking class calendar. Pwede kaya tayo sa second week of March mag-exam? Ha? Isali ko lang yung ano, yung mga assignments, grades. Okay? March. So we have more than a month, okay? Maybe 6 weeks. Okay. So, pwede na tayong mag-asynchronous sa pagka-third grading na. Basta madali lang tayo matapos. It's okay. So remember, no? 32-bit yung PCI. 16-bit yung ISA. 8-bit yung ISA. Okay? Bye, everyone.
Yes, sir.
Bye, sir.
Bye, sir.
Thank you, sir.
Thank you, sir. Bye, sir.
Thank you.